Okay folks, welcome back. So this is video number 26 in this playlist where I'm kind of demonstrating how to use R to do some quite basic statistical and data analysis tasks. So in the previous video I recorded instructions how to conduct the independent groups t-test, and in this video I'm going to follow that up by demonstrating how to run a repeated measures t-test. So hopefully you'll recall that the t-test it's a test that is frequently or normally used to compare mean scores between two groups. But in the case of a repeated measures t-test, or sometimes known as the paired samples t-test, what we're actually doing is we're comparing scores for two groups, but it's actually the same participants. So it's in a repeated measures design, your participants are contributing more than one data point. So what we're doing here is we're looking to see if there's a difference between scores at time 1 compared to time 2. So quite a common design really in psychology and the behavioral sciences. So the example I'm going to use is kind of made up simulated data, as it often is, and it has the properties that I want it to have, so we can demonstrate a significant repeated measures t-test. But so examples of the type of design you're commonly likely to find a repeated measures t-test, where you've got kind of two different time points. So maybe you've got a group of participants and you measure say their depression, or you measure them on some particular variable at time 1. You then give them some sort of treatment or intervention. So maybe you measure how depressed they are, then you give them some sort of treatment like cognitive behavioral therapy or something, and then at a later time 2, you then measure their depression again, and you look to see if there's a difference in their depression scores between the two time points. So that's kind of an example. The example I'm going to use here is the data set that I'm going to import. We'll look at this in a second. Test score progress. This is kind of a very similar thing, but it's just looking at participants' scores on a test, on one test, and then on a test they take at a later time. So this might be an example. This might be in education. Maybe at the start of the year you give your students a test to see what their baseline knowledge is. Then you teach them the curriculum, and then you give them a test towards the end of the year, and you look to see if there's a difference. So if they've learned something, then there should be a significant difference in their score. They should get a significantly higher score at a later time. So I'm going to import the library, the tidyverse library. So I'm using that library function, tidyverse. I don't really think we need the I'm going to do a little bit of data reshaping, so maybe we might need the tidyverse for that later on. But most of what we're going to do in this particular video, in this particular example, is the commands that I'm going to use are base R packages, so they come installed kind of with the base R installation. So what I'm going to do first of all is I'm going to create a data frame. I'm going to import this data set. So I've got this CSV file, this comma separate values file, like a spreadsheet basically, saved in my working, let's have a look, files, saved in my working directory for this particular project. You can see here above the console, if you just look where my cursor is, you can see that I am in a particular project folder, and these are the files within that particular project, and test score progress is one of those. So I'm going to import that using the read.csv method. I've demonstrated this in previous videos. So I'm going to use the read.csv method within quotes as a string, passing the name of the file that I want to import. And I'm going to save this. I'm using this assignment operator, save it as an object called df, so data frame. If we run that, you can see here in our environment that df's been imported successfully. It's a data frame. You can see there it's described as there's 50 observations of 3 variables. So we've got 50 participants and we've got scores on 3 variables. Let's just use the head function on df, and we'll be able to see in the console window below what that data, just the first few lines of that data frame, what it looks like. So the three variables are, the first variable is not really that interesting, it's the participant ID, it's just the ID number of the participant, 1 to 50. But then as separate columns, as separate variables, we've got test 1 score, so the score for test 1 for each participant, and then the next column test 2 score, so their score on test 1. So you can see participant 1 here, they scored 45% say on test 1 and then 55% on test 2, so they had a higher score on test 2. And what we're gonna do is use this repeat measures t-test to see if there's a significant difference between the mean score for participants on test 1 compared to test 2. Okay, another command I like the glimpse command. I've shown this before. Gives us kind of just a list of our variables, but it also provides us useful information about the data type. So it says all three of these are shown as integers. The participant ID I'm not too concerned about really. It's just a kind of record to show to identify each participant uniquely and align them with their scores. But the other two are shown as integers, so we can use them to do some analysis with. We're not going to have to change the data type. As if they were floating point numbers, decimals, or integers, they'll work fine. All I'm going to do, just so we can see the means for those variables as a whole, I'm going to use the mean function, and I'm going to call df and then dollar and test 1 score. So I'm asking for the mean score for test 1 for this whole group, and you can see that the mean score is 41.36. I'm going to do the same then for that second variable, test 2 score, and you can see the mean is 52.72. So the mean is much higher for this second group than this first group, but what we're interested in knowing is that statistically significantly higher. So is it a statistically significant difference between the two? Okay, so to run a paired t-test, we kind of we've seen this before. The syntax for a t-test in R is t.test, and then you specify different parameters, arguments in brackets, in parentheses afterwards. So here I'm not saving these as separate objects, but I'm doing t.test, open in parentheses, then I'm saying df $test1 score. So the first thing I'm saying is take the test 1 score, then a comma, then df $test 2 score. Same thing again, really. I'm saying take the test 2 score from the date frame, df, and then I've put this extra comma and then another argument there. I'm saying paired equals true. So the default would be false. So it'd assume if you just passed it data that what it's looking at is a independent groups between subjects design. But in this case, the data points are not independent. Each participant contributes 2 data points in this data frame. So we've specified the correct argument here. So if I run that, you can see here we get the output below. We get a paired t-test. We've got a t-value of negative 23.729, 49 degrees of freedom, and a p-value of less than 2.2 times e to the negative 16. So we'd have to move our decimal place 10 places to the left to get the actual 16 places, sorry, to the left to get our actual p-value. So it's a very, very small p-value. So what this is telling us is like a very statistically significant difference, highly significant difference between the means of the two groups. You can see it's presented the alternative hypothesis. The true mean difference is not equal to 0. So if the mean difference was 0, then effectively there is no difference in the mean score, statistically significant difference. But this is telling us there is a statistically significant difference. And underneath you can see we've got this negative 11.36 as the mean difference. So the reason we've got these negatives here for the t statistic and obviously the mean difference is just a function of which argument, which of our variables I passed in as the first argument rather than the second. So I passed in test score 1 first and then test score 2. So when it's done the t-test calculation for a paired samples t-test, it's subtracted test score 2 from test score 1. And we know kind of the mean on average was lower for test score 1 than test score 2. So it's given us these negative values. So we could just ignore these and interpret this Ignore those negative signs and just specify the absolute value and the absolute value of the difference. But if we, just to illustrate this, so if I do the t-test again, but this time notice I've put test score 2 first as the first argument, then test 1 score second as the second argument. This will give us the same result, but on this occasion we won't have the negatives because it's subtracted the scores that were lower from the sort of lower group, test 1, from the one with a higher mean score. So we've ended up with, subtracting smaller values from higher, you're going to end up with positive scores. Subtracting larger groups from smaller, you're going to end up with negative scores. Okay, so that's it. Pretty simple, really, for a paired samples t-test. But one thing to note here is, let's scroll back up a little bit. When we're looking at our data frame, so the data frame in this case was conveniently in kind of wide, short and wide format. So test score is effectively one variable, but it's split across 2 columns here, and that's useful for running this particular paired t-test. But the problem is, most of the time your data is going to be in kind of long and thin format. That's the more common format to find your data in, and it's the best. It's the way I prefer to work with data. So what I'm going to do now is I'm going to import another data set. I'm going to call it df2, another data frame, and this data test score progress long. So it's exactly the same data that we looked at before, but it's in the long thin format. So if we look here, we've got data frame 2. df2 has imported successfully. There's 100 observations of 3 variables on this occasion. So if I do the head, if I call the head function or method in df2, what you can see is what I've done in this case is, rather than 2 columns of test scores, what I've done is score is one variable. So it's got 100 scores there, and the first 50 relate to test 1. So the second variable I've created a new variable called test and shown it as 1 and 2. And if I call that, obviously can't see it because the first 50 are 1, the second 50 are 2. But if I call the tail, you can see the bottom few rows of data. You see test 2. So we've got 100 rows here, 100 scores, and 100 categories for test. 1 being test 1, 2 being test 2. So this is now in a long and thin format. And if I try to do what might seem like a logical thing and conduct, I know whilst it's in this long thin format, df2, conduct a paired samples t-test on it, we will get an incorrect result. So I'm doing t.test, and I'm basically specifying my arguments, but they're the incorrect. So I'm saying I want my kind of x variable to be test, which is group 1 or group 2, test 1 or test 2, and effectively what might be considered my dependent variable, df2, as the score, and I'm saying paired equals true. And it will produce some output there, but it'll give us a very incorrect very incorrect result. It gives us a significant result, but the mean difference is way bigger than the mean difference between those 2 groups. The problem we've got here is what it's done is it's basically worked out the mean score for test, and then it's worked out the mean of the score variable, and then it's compared them effectively like they are time point 1 and time point 2, but these score is very different. That's our test score from the category of tests. So category by which I'm saying whether it was their test 1 score or their test 2 score. So to get around this, if you've got your data in long and thin format, you might be thinking, well, how am I going to do a paired samples t-test? And the way to do that is effectively to reshape the data. So what I'm going to do is I'm going to create, from df2, I'm going to create a new data frame called df3. So I'm going to assign the output of this syntax here to a new data frame 3, df3. I'm going to use the reshape argument. So I'm going to reshape that long and thin format into a wide, short and wide format so we can effectively do a t-test. So what I'm doing is I'm saying reshape, and then I'm opening parentheses. I'm telling it I want to take data frame 2, which is a long and thin data frame, and then putting a comma. I'm specifying direction. So this is the direction in which we want to reshape it. So we want to go from long and thin to wide. So I'm saying direction equals wide, another comma, and then I'm specifying, so because we know each participant contributes a separate data point, the ID variable, it accounts for that, or keeps track of that. So in the data frame, if you look, that's participant ID. So what I'm doing is ID var is participant ID, and notice this is in quotes, as is wide, and it's written exactly as the name on the data frame. So with a capital, with an underscore, with 2 capitals there. Okay, then comma, and then the time variable. So this is our different time points, and then specifying that to be our test variable. So time point 1, test 1, time point 2. So if I run this, what we should now get is df3 should take df2 and change it back into the same shape, really, as our first data frame. And that seems to have worked. So if you look here, we've got df3, 50 observations of 3 variables. And if I call the head method on df3, what you'll see is it's given them slightly different names to the score variable is split across the 2 columns. So we've still got our participant ID, but we've now got score.1. So that's score for test 1, score.2, score for test 2. Okay, so when we run our t-test, what we now need to make sure we do is use these this version of the name that has been created by our running that reshape function. So I'm going to run it here, and hopefully, if this has worked properly, we should get the same result as we got above here, 11.36, etc. So I'm doing t.test. We're taking data frame 3 $score.2. So I'm taking the test2 score as the first argument, subtracting df3 score.1, their test 1 score from that. And again, I've specified that that it's a paired test by using this paired equals true parameter. And there you go. If you look at, I've run that. If you look at the output below, what we're getting here is we're getting the same t-value we got before, still highly significant, and the mean difference 11.36 is the same as we got previously. Okay, so just something to be aware of there. It looks like running a test like this is quite simple. But you have to think about the shape, the format of your data, and you might have to reshape it in order to conduct this test successfully. Okay, right, so that's it. That's all I'm going to say in this particular video. Thanks for watching and listening, and I'll record another one soon.